Alright champions, let's wrap this one up, eh? So a summary of what we did, starting from the front: new input jacks, new grid stoppers and grid leaks on the input jacks, new coax for the input jacks. I left the existing coax there for the volume pots. The occasional drifted resistor replaced, those two plate loads, that slope resistor. There was a bunch of resistors already replaced by the previous tech. They were all within spec and there's nothing wrong with them, so I put them back in. Reconnected this eyelet as you saw in the last one. Lyle commented on that and I agree with what he said, but that actually came up pretty well cleaning up in this area. There's not more than a millivolt or two on those points now anyway. Over here we lifted that plate load HT feed, so now all those wires just connect straight to those that junction there, so that frees up that eyelet right next to this, which is connected to the grid of the next stage, so we don't want scratchy behavior or things running out of bias. All the knobs I've still got to take off and give them a clean, although, you know, one might argue what's the point. But I aligned them for the moment because some of them were like set at 0 when they were at like 5 and stuff, so now we at least know where we're at. What else do we do? New reverb tank, that's a new MOD down there. I've just got a temporary cable up here just testing on the bench. It's fine. Redid the connections at the back here, cleaned the RCAs, shortened leads, tidied up solder joints all over the thing. Put it back together, I gave it a bit of a test. No tremolo, so the roach wasn't working, so the neon was oscillating and the oscillator was oscillating, the neon was working, but the LDR wasn't responding. So new roach it gets. This resistor is known for cracking its joints, so I'll put a new one in with some expansion, little sort of folds in the lead there, crimps, whatever you want to call them. New bias supply as per the last twin. That allows us to adjust the overall bias with that trim pot and then the balance with the original pot there. Move the bias feed resistors off the board and wired them directly to the pot, so now they're not sensitive to HT from, just separate those caps, there we go. So that used to be on that other eyelet, as mentioned in the previous one, to that junction there was leakage which would cause runaway in the output stage. So now that's addressed. The original screen grid resistors and grid stoppers, okay, I left them in. Put some flyback diodes in there, R5000Fs, fast recoveries. Put some backup diodes on the rectifier, cleaned up the rectifier wiring, shortened the mains lead because it was pretty munted, gave it a dedicated grounded point there on an area that I cleaned up on the chassis, removed all the grounding points from the transformer hardware, cleaned up the chassis and soldered them to their dedicated spots, rebuilt the bias supply, cleaned that board as well, cleaned this board as good as we could. I removed the insulator board, cleaned underneath, got rid of a lot of blobs of soldering. You saw all that in the last video, part 2. Reinstalled it. All is fine and dandy now, and it's performing very well. This is meant to go into a 2 ohm load, so I've got my usual 8 ohms there in parallel with another 4 ohm across that in parallel to give us 8 ohms. I removed the 4 ohm for audio testing. I've got a 16 ohm, never mind the probiotics yogurt over there. That's my little bin that I put all wire scraps and stuff in. And there's my ThinkPad, not really thinking much right now. I put that 4 ohm resistor in parallel when I'm running it with the 2 8 ohms in parallel to give me a total of 2 ohms, sorry. Yeah, we replaced the speaker jacks too, that you can see they're suspiciously shiny. Cleaned up the wiring there as well, shortened the wiring to the reverb transformer. Anyway, back to the dummy load. When I remove that 4 ohm, I plug in my 16 ohm under the bench and it gives me about 3 ohms load, so I can test it at a lower volume and just know that nothing weird's happening. And I'll do a test through that speaker in that configuration. We'll do some audio samples and then we'll put it back in the cab, and I'll dodge up those speakers, put some screws in there so they're sort of secure, even though he didn't want to include that. I can't send it back how it is. Rewire it and see what the speakers sound like as well. So we'll do a double test. We'll test it on the underbench test speaker, which is a Celestion G12T75, whatever it's called. I forget which order those letters are in, and the original 4 speakers in, well, original 3 speakers and the odd one out up there. So just quick running over the valves. All the stock JJs and 1-tongue sole preamp valves are all fine. I've reinstalled them, and we're going to run with the GZ34, even though this originally had a 5U4. And I'll put 2 new Tube Amp Doctor 6L6 GC STRs in, the red base, the short bottle ones, which is nice. Means I don't have to put blocks under the amp while I'm testing it. And we've balanced them up and they're performing well. So let's fire it up, see how we go. Click, bang, smoke. Drawing about 50 watts there. I think it's settled down to about 50, 49 in standby, and as the rectifier warms up, you can see it's starting to deliver voltage now. That's a meter on the right. The other 2 are measuring the drop across the output transformer, and as they start to conduct, away they go. You'll see the voltage peak there and then drop back down a bit. There it goes. Oh, stabilised at about 477. It was about 480 yesterday, but that's mains fluctuation. Alright, so it's running a little bit cooler today, possibly because of mains fluctuation, but I'll give that another tweak. Let it stabilise for a bit and then we'll do some testing. So we've stabilised there. I've balanced and set the bias to bang on 50%. Now we'll do some sound testing. Well, first I'll test for output power, then we'll do some sound testing. Leave yous hanging. So we're going into a 2 ohm load. We've got the voltage readout up the top there in RMS, and we're going at 1 kilohertz. Crank her up. Just starting around off there at bang on 9 volts, which is about 40 watts. Push it harder into clipping. It approaches 10 volts, which is 50 watts. So that's about what we'd expect from this amp. And after adjusting the bias, sitting in play mode with no signal, quiescent, it's just sitting on 90.5 watts. That's at about 242 volts input. Now you can see on the scope here there is a little bit of ghosting happening when you hit up your higher registers. I'll synchronize it to the mains frequency so you can see the ripple on the top and bottom of the waveform and know what I'm talking about. That gives you a way to visually represent what you're actually hearing. It's the difference between the two notes, the note that I'm playing and the 50 Hertz coming from the mains rectified to 100 Hertz. So it's the resultant frequencies coming from that. So just changing over the reverb tank, the bag's all cut up and no screws securing it, so that was just floating around. If it was on its back it would have fallen out. Got a massive long lead here, not sure why, it's probably a replacement. And there's all the bits and pieces of speaker wire, so I'll disconnect all of this and probably just snip it off, see if I can clean those terminals first, because they're pretty bad, and see if we can get any solder to stick to them. Well, I couldn't let the thing go out with every speaker holding on by 2 screws or 1 screw, so what the hell? I only just noticed that then. What? I literally just took the grill off to put these screws in, and I just noticed there's a screw going through the fucking dust cap. Like, really? Oh my god, stuck to the magnet. I'm over this amp, really. How does this stuff happen? So there's one of your bolts. It got sucked into the magnet. How does that even happen? I don't know. I'm at a loss. Anyway, it's time to get this thing together and get the hell off my bench. That's what the grill cloth does when it degrades so badly that it just turns to chalk. I just sat it on the ground, and this is all the you know, frayed thread. Every time you touch it, stuff just falls off it. It's really gross. Alright, so they're all secured by 4 bolts now and 4 nuts. I found some Kep's nuts that were the right size of my little stashy McStash face. So I'm gonna, you know, OCD got the better of me once again. This is why I'll never be rich. I'm gonna rewire all the speakers using my own wire. This stuff's just so stiff. The plastic's so degraded. It's just unworkable. It goes in the bin. And as with that stuff, it's just so stiff and crappy. So in the bin. And I've got my trusty 30th anniversary Makita here, making nice little twisted bit of wire there for my new loom. Poor old bastard's seen some shit, I tell you what. It's built some houses for billionaires, and it's done things for people a lot not billionaires. Alright, so we'll use that, parallel all of these up. They're all 8 ohm drivers. I've checked them all for continuity, and that's good. That's one win. And I'll reuse that Fender plug there, just for originality's sake. And there's our shiny new wire. It's going to stand out like dog's balls in the back of this amp. So interestingly here, you can see the springs have been smashing around on that cardboard, and deposited a bit of their plating on that cardboard. We've got the new tank going in there because the old tank's coil's open. It looks like someone's repaired the coil at some point and it's lost continuity again, and the wires have been resoldered, looks like multiple times. So yeah, I don't trust that coil even if we could repair it, which we can't. It's just going to fail again in the near future, so we'll put a new MOD in there as we tested it with, and happy days. I switched over to my 9mm lens. I love this thing, Leica f1.7. Slimming. So I'll try and remove the excess solder off these spades, and a bit of Scotch Brite, some swearing, and we should be able to make a connection to them again. Right, so we've managed to clean up the terminals with a little bit of swearing and stuff, and some wire brush, being careful not to get any fibres down in the speaker cones. Now, someone commented on another video, when I always say we've done this, we've done that, what the hell am I talking about, because I'm here by myself? Well, it's me and you, champions. We're fixing amps together. Just don't ask me for a paycheck. It'd be nice if you turned up to work once in a while though, eh? So here we are, halfway through wiring up the speakers. You can see here, can you see here? Thanks Panasonic. I've actually folded the wires over, so you've got a mechanical connection before you even add solder, instead of just tack soldering them, like almost every amp that comes in here is. So do that, and you'll almost reach, you know, Gandalf the Grey levels. Alright, so here I've got the function generator just going straight into all 4 speakers parallel, just to show you the cone cry, we call it, voice coil rub essentially. So we're starting at 0 Hz, low amplitude. You can hear it sort of kicks in there. And ironically that's the replacement that's doing that, worse than the others. You go up and it goes away again. Until you hit another frequency. Around there, sounds a bit square wavy again, and that's one of the other drivers doing it at a different frequency. So let's try it at higher amplitude. So it seems like there's a higher frequency, one of these other 3 is doing it. It sounds like multiple, like these 2, and at a lower frequency this one's doing it. But they're all working. You're just going to get some distortion and weirdness at lower volumes in the lower registers when you're playing cleanly. So yeah, I mean, if you were using a distortion pedal or something, you probably wouldn't even notice that, but it's just for the quiet passages and the clean guitar, particularly jazz styles with a darker tone, that would really stand out and be annoying. And just like on the Twin the other week, flexing the basket around changes how bad it is. So that goes to show that the pole piece is distorted, and moving the frame around affects it.